Hi, Chapter 8, Lesson 2 gives us the beginning of our laws of exponents. That is my cat. She's looking at the calendar. Yeah, she's sorry about that. You've always wanted to see her. There she is. Her shadow. She exists. Okay, you're going to have numbers, actually, scientific little problems like this, where you'll have something like 5.9 times 10 to the 12th multiplied by 2.2 times 10 to the 6th. You may remember this from pre-algebra, but you're going to take the numbers that you have and you're going to multiply those, and you're going to take the bases or your powers of 10 and you're going to multiply those by each other. Okay, when you do that, you end up with 12.98 times 10 to the 18th, because you simply add these exponents together when they have the same base. Okay, but of course, as we learned in our last lesson, this is not proper scientific notation form. Let me move my camera a little bit. So we have to move that decimal, and we end up with 1.298 times 10 to the 19th, because we make this number smaller. So we have to make this number that many times larger. 10 times smaller, 10 times larger, but it just adds 1 on the exponent. Okay. I'm sure that you know this, but x is your base here, y is your exponent. Okay, and that is important to know the lingo for math. Sorry, here we go. Okay, x is your base, y is your exponent. Know the lingo for math. Your first law is simply this, is that x to the a times x to the b equals x to the a plus b. And the law simply states that to multiply powers of the same base, okay, they have to be the same base, add the exponents. And I'll show you why. It's pretty simple stuff. Okay, if you had 2 cubed times 2 squared, and I just said that backwards, but that's okay. I could write it out, 2 squared as 2 times 2, and I could write out 2 cubed as 2 times 2 times 2, and then I can do for my answer 2 times 2 times 2 times 2 times 2, which is 2 to the 5th. Or I can simply add the exponents, because I have the same base, 2 to the 2 plus 3, or 2 to the 5th, which gives me my answer. And since math is all about efficiency, we're going to do it the easy way, I hope. Okay, you can do the same thing if you have variables for your bases. If you had x squared times x cubed, you can simply add your exponents, x to the 2 plus 3, which gives you, x to the 5th. If you had x times x for the x squared, and then x times x times x for your x cubed, you can then add those up and get x to the 5th. So if you like to use a lot of pencil and paper and use a lot of time, you can do your math this way. Or you can simply add your exponents and get the answer. Now, when you have problems like 2x squared times 8x to the 8th, nice little problem there, you're going to multiply your 2 times your 8. Okay, those are your coefficients, your numerical coefficients. You're going to multiply those by each other. And then the base is considered the x. That's the only thing that's attached to that exponent. Okay, so in this case, your base is x, and then you have 2 exponents, 2 plus 8, so you have 16x to the 10th. Okay, important to recognize that this is not attached to the exponent. Now, if it had been written like this, it would have been a different thing, okay? So it would have taken another step, but we don't have to worry about that yet, because that's another law, so don't worry. Okay, now if you have scientific notation, you're going to do 2 times 4, which is giving you 8, and then you do your bases of 10, your powers of 10, 2 cubed, and then 10 to the 5th, 10 to the 3 plus 5. So now you have 8 times 10 to the 8th. And this is proper scientific notation form, so you can leave your answer just like that. However, if you had this problem, 4 times 10 to the 5th, times 9 times 10 to the 5th, you would take your 4 times 9, and you would end up with 36, times your base of 10, and then your exponents, 5 plus 5, or 36 times 10 to the 10th. Now, I know it's beautiful, but it is not perfectly correct, okay, because this is not in proper scientific notation form. We can only have one number to the left of the decimal, so we're going to move that imaginary decimal where it should be, and we end up with 3.6. When we make 36 smaller by 10, then we're going to make this exponent larger by 1, okay, which of course 10 to the 10th to 10 to the 11th is multiplying it by 10. And that is the same problem written in black ink. It's beautiful. I hope you have a great day.